Welcome to TaiyangNews Very High Power Solar Module Virtual Conference, organized like usual by our team based in India, China, and Germany. My name is Michael Schmela, and I'm the Managing Director of TaiyangNews, a solar news platform focusing primarily on technology. So first of all, a big thank you to our sponsors. I'm very glad we could win this time the majority of the top 10 global solar module manufacturers to sponsor our event. That's the way we can keep it free of charge. And I'm also happy this concept works. We have now nearly 800 registrations from around the world. With, as I could see so far, many of the key stakeholders of our sector having signed up. So that's a great, great message to start. From an organizational point, just like usual, I just want to try to explain. So we try to keep our events very simple. That's why we use Zoom, which is known and accessible everywhere. So please use the chat room function, not only to ask questions to presenters, but in general, and also to answer these questions and really also the comments. So we see this somewhat as a virtual coffee room where you can chat with anyone around publicly. So this is the Q&A room. Please use that for both asking questions to the presenters, panelists, but also to discuss with others in this conference. About this event, we've all seen, of course, a real boost in module innovation, especially in the last 2 years. There's much more power, higher efficiency, through different means on the module level. So last year we organized our 500 watt plus conference with the key players pioneering these products presenting. And now, about 1 year later, many module companies are walking this path, and modules have continued to get more powerful while addressing at the same time also the different segments, from residential to utility scales. So that's why we're organizing again an event looking at very high power solar modules, and that's how we intend to continue that also in the future. As the trend to more powerful and larger modules has obviously also an impact on the whole value chain, we have created a 2-day event. On the first day, we will focus exclusively on modules, while on the second day, we will also talk about modules and balance of systems, and have also leading inverter companies presenting their latest updates. And some of the module companies that are also active in other fields will talk about that as well. So one important difference for this event is also a preview to the upcoming SNEC or SNEC 2021 in Shanghai, which takes place in early June. This is not only the world's largest trade show, and due to COVID-19, the only major one taking place this summer physically worldwide. But SNEC is also the compass for any major trends in the solar sector. So we are really excited that SNEC is supporting us here, our event here, and obviously also about what the market leaders at our event are able to share 2 weeks ahead of the show. We hope it's a lot. Today we first start with my colleague Shravan Chunduri, providing a first peek into the research for our upcoming very high power modules report. It's a pre-launch. The official launch will be during SNEC, where we will publish and also distribute printed copies of the report. Shravan's presentation will be followed by VDMA, and I'm also very happy to have them here to share the latest on module findings of their recently published international roadmap for photovoltaic, ITR PV. That's also a key compass for the sector, so it's great to have them here. And I'm also very happy to have TÜV Rheinland to present its experience on testing and looking at the large module formats. And then and that's also great, we move into the presentations part on the latest products update. And today we have with us LONGi, JA Astrology, Jinko, before we conclude then the first day with a panel discussing the latest module trends. Okay, enough of introduction. Let's start with my dear colleague and head of technology, Shravan Chunduri, who I worked with many, many years ago already at Photon International, and who has been instrumental in getting both our publication on TaiyangNews and our consulting arm, Mishko, flourishing. Shravan, we're excited to learn about your research on very high power solar modules. The floor is yours.
Thank you, Michael. Thank you very much for this nice introduction. I'm just trying to share my screen. You can see it, right?
Yes.
So, hello everyone. As Michael just introduced, I am Shravan Chunduri, Head of Technology. And today, I will provide an overview on TaiyangNews report on very high power modules, which we are planning to publish very soon. So before going into the main topic of my presentation, I would like to give a brief introduction of our company. We are actually two companies, and we are two platforms. TaiyangNews is an open platform. As you all know, we publish reports on advanced PV technologies. We also publish the market surveys on various production equipment and process consumables. So the differentiation with the TaiyangNews is that it is an open platform. That means all the publications what we publish on Taiyang platform can be accessed for free. And Mishko is our consulting arm through which we provide services, of course, at a fee. And our services include communication strategy development, technical research, and market intelligence. With consulting services, we kind of go much more deeper into any specific topic. As you can already see with our free platform, we are already doing that. What I am presenting today is the preliminary results of our upcoming report on very high power modules. So what you can expect from the report is it will discuss the developments associated with very high power modules along the three important parts of the process chain. So wafers, cells, and modules. The report will also provide a preview on what to expect at the world's largest solar trade fair, which is SNEC, which will be held on 3rd to 5th of June. And so the report will also offer an update on all module products on offer so far. Yeah, so coming to the main topic of my presentation. So as you all know, increasing wafer size and increasing the module power has been one of the most hot topic in last year, and this topic is still getting extended into this year. So when looking at what really is motivating the module makers to increase the module power, it's basically coming from the savings of BOS cost. So, as you can see from the graph here, This is a graph from Longji Solar. They showed at our 182 mm conference. So according to Longji calculation, if you increase the module power by 50 watt, there could be a savings of 0.8 cents per watt in BOS cost. So, but going further deeper where these savings are coming from, it's mainly coming from the string power increase with higher module power. So that means if you have fewer strings that are required to attain a specific capacity, and the fewer strings would obviously reduce the BOS cost. But there is also a catch here. The module power has to be increased without increasing its voltage. So otherwise the number of modules per string would remain the same, because a string has a limit for its voltage. So that determines the number of the modules that can be connected into a string. So that is why companies have started to increase the module power without increasing the number of the cells, because voltage is a function of the bulk, whereas surface is a function of current is a function of the surface. So that means if you are putting more number of the cells into a module, you are increasing the voltage, whereas if you are increasing the cell size, the voltage would remain the same, but the current will increase. So that's how this concept of larger wafers has really guiding the PV industry from 1.5 year, I would say rather close to 2 years. This is one of the most important development that is still going on. So discussing what's really what has developed in the recent time. So increasing wafer size was actually, as I explained earlier, it is one of the most straightforward way, and the 156 mm actually remained as a standard for more than a decade, but then slowly M2 kind of replaced it because there was no fuss about it, because it doesn't need a lot of change in the production. But then very soon G1, M4 and M6 were introduced. Something like in M6 came into the market somewhere 2019 mid, and then in 2020, by end of 2020, already modules based on larger wafers have surfaced. So Ryzen was the first company. Here you can see in this graph, like several companies have introduced very high power module within a short span of time. So another important trend, what we have also observed is through our recent conferences, be it 182 mm based or 210 mm based conferences, module makers are really increasing their capacity humongously, I would say, because if you when we heard the announcement of Longji, they really want to go for 105 gigawatts of wafer, and they already had 50 gigawatt in last year. Now they want to go to 65 gigawatt. So this is also one of the most important trend that's also mixed with going into higher module power. So that means employing larger wafers. So as I explained, so the crux of the increasing module power lies in wafer size. So that means earlier standard, which was M2, it's kind of fading off, and G1 and 166 mm, which is M6, they are trying to kind of replace. But I think even this is, many think that this is an intermediary step, and a lot of companies have already moved towards the larger modules. But here, as you can see, there are two routes from going from M6. So one is M10 and another is G12, as you all know. So vertically integrated companies are really pushing for M10 format, and cell and module companies who are not really bothered and are not burdened with any wafer capacities, they are trying to opt for G12. But that's not only the case, because till last year it was mainly like these were the two major camps, M10 and G12. But now a few intermediary manufacturers who want to take who want to play a safe game, so they are even trying to do both M10 and G12. These will be discussed very in detail in the report. So and as I already mentioned, TaiyangNews has already covered these two topics exclusively with our conferences in previous sessions. So here I just draw a wafer price trend line. So what does it tell is, of course, so wafer prices are increasing, but one of the most important way to reduce the wafer price is to reduce the wafer cost, is to make the wafers thicker. So as you can see right now, the G1 and G1 M6 and M10 are the current mainstream wafer sizes. At least this is what we learned from the Longji's quote. And wafer thickness has also been reduced. This is a very good progress, because as you can see here, the M10 was only available in 175 micrometer thickness till April. But by mid of the May, Longji has started offering these 170 micron thickness wafer. And what we also heard is G12 capacities are also building up, and right now the main wafer size for G12 is around 175 to 180, but there are also efforts to reduce it further. And current status. So as far as the benefits of what is the right direction to go towards, whether to go towards G12 or M10. So what we try to do is we evaluate different parameters all along the value chain. So first comes the crystal growth and wafering section. But what we can see so far is there is no clear path, because if you are hearing to Longji, obviously they would support M10 format. But if you hear to Ryzen, they are going to say, okay, G12 got the benefits. But I think there is some slight improvement required at ingot growth process, because growing larger ingot requires a little bit more time, and there are also concentration that has to be controlled, and this is also making a little bit complex. But on the other hand, M10 right now seems to have achieved a very close, try to achieve parity to M6 wafer format. But I think the work is really progressing. So this is the update what we got in December. Probably we will hear more from these companies in this conference as well. I think the changing to larger wafer sizes has a large impact on the cell manufacturing. But I think one that should be applauded here is the equipment makers. They really did a very tremendous job. So not only making the equipment suitable for different or I would say largest wafer format, but at the same time, they have also tried to scale up the throughput. So the overall capacity in terms of gigawatt metric has really boosted up. So for example, here you can see this is the throughputs for different wafer formats, something like M10 and G12. So another important thing what I would like to highlight here is the same equipment can also be tweaked to process even higher or lower. So if you are at M10, you can go to G12, or if you are at G12, you can go to M10. So this kind of flexibility is really provided by the production equipment. So as far as the M2, what I hear from the most of the production equipment makers, so running such lines is doesn't make economic sense anymore. As far as the PERC line is concerned, so every production, every tool for every process step in PERC line have been already upgraded for processing up to G12 formats. And but there is also equal amount of effort to improve the process equipment for making high efficiency architecture. So few companies most of the companies are already ready with the TOPCon solutions, because what you especially need for TOPCon are some specific equipments like boron diffusion and LPCVD furnaces. I think since they are also very close to the PERC equipment stream, they're already there, but heterojunction, what we hear is they are under development. And coming to the module, actually the effort what is required for making modules compatible for larger wafers is very less. Last year there was some concerns about the bill of material glass, but I think most of these bottlenecks have been cleared. In addition to making not just relying on the larger wafers, module makers are really wrapping up a lot of other advanced module technologies into these larger modules, something like bifacial, half cell, and things like MBB, and narrowing the gap, and even the reflective ribbons. And so one of the most important trend what we see here is all these modules based on larger wafers, they are either half cut or 1/3 cut, and most of the companies are employing non-destructive cutting methods to reduce any breakages or any damages arising due to the cutting. Interconnection with multi-busbar, I think this is more or less again became a standard. Nearly everyone is kind of employing, but here it really depends, as you can see here. So the number of the bus bars, I mean the circular copper wires, how many they are going to integrating, this is also depending on the wafer size on one hand, also number of the cuts. So for example, Trina, when they are doing the half cut, they are employing 12, but when they are doing 3 cut, they are employing 10. So you can also see the same thing here at the Ryzen. And some companies have also, whenever doing the larger cells, they are doing definitely the larger number of bus bars, which is 12. Then another important technology trend that kind of also came along with high power modules is reducing the gaps, and here a lot of companies are making big efforts. So for example, Jinko, they have their Tiger module, which is no gap technology, but not everyone is yet there, but they made a considerable progress in reducing the gap, which was earlier, like for a standard module, it was something like a 2 mm now, which is brought down between 0.5 and 0.9 mm. And these are the products. So what we see is, as I mentioned, so some companies are really strictly following the M10 way, which is Longi, Jinko, and JA, Ryzen and Trina. They are taking the G12 path. So companies like Astroenergy and Jollywood, they are really taking, have launched, are going to introduce the module based on both G12 and M10 formats. So as I mentioned here, one of the most important factor that is determining the power of the module is how many number of cells that are integrated, and then how large is the cell. So as far as the configuration right now, I will show in the next slide, like modules based on very large configuration. So as you can see here, right from 54 to all the way, 78 cell configurations available in different mix and matches of wafer sizes and slices, how many slices they are cut into. So all these are going to affect the module power. So I think you will hear more regarding the power and specific product development from each company. But what is surprising is Jollywood has already reached a 700 watt with its TopCon module, which is a G12 wafer based and 66 cell count. So here I come to a conclusion. So what I want to do here, what we really learned or observed over the last year, I think with regards to wafers, there were a lot of concerns, especially for the 210 mm about the supply. I think what we also hear is one or two companies are going to be online by end of the year. So this issue, I think, will be solved. As far as the cells, production tools are really available for PERC and TopCon already, and things are underway for heterojunctions, for modules. There are no issues from the BOM. And as far as the products, as I just mentioned, so there are really a big mix and match of configurations available, all the way from utility scale to even the residential scale modules with smaller sizes still built on the larger wafers. At the system level, there were concerns like inverters, trackers, there might be some issues, but I think the custom-made solutions are also available, and some of these products have also entered the mainstream. So, but one thing is for sure, so modules cannot really grow endlessly, because there is a limit in terms of weight and also the size. So this again bringing back to the same point, like module makers have to look into cell technologies to improve efficiency, again to progress in this path. So now we are really excited about the pre-SNEC news from the market leaders. Thank you very much, and thank you, Michael.
Thanks, Shravan.